the Richtersveld, scientists have uncovered something extraordinary, a completely new genus and 6 previously unknown species of beetles hidden in a desert many assume is almost lifeless. So we're joined now by those 2 scientists behind the discovery, Roman Borovec as specialist in beetle morphology and classification, and Massimo Meregalli, an expert in weevil evolution and DNA analysis. Dr. Borovec, Dr. Meregalli, a very good evening to you both, and thank you so much for speaking to us.
Thank you very much, and we are very happy to make this interview for South African Broadcasting Corporation.
Roman, let me start with you.
Good evening also from me.
So let me start with you, Roman. The discoveries of this brand new genus, it's extremely rare, but just how unusual is it to find not 1, but 6 new species at once?
Western part of South Africa is very dry, fine boscaru, succulent bush, semi-desert area. Collection of edaphic insects in these moderately difficult conditions is not easy. Edaphic insects are insects living in soil, in roots of various plants. It means to sift not humid, green habitats, but very dry places, many times even dry sand. Nobody before us tried to collect in these conditions by sifting of roots of plants. We were able to find method in our trips how to search for these small beasts and also how to find insects in the soil, which is not easy because they are mimetic, slowly moving. If they don't move and staying, you cannot see them. That is why material collected by us is very unique. And because we examined plenty of material in South African and also European large museum, we can say it is material nobody collected before us. These edaphic insects have in South Africa incredible species diversity. 6 new species we discovered in our last trip is based on our experiences to collect this material. And mainly we had possibility to visit localities and habitats nobody collected edaphic insects before us. One brand new genus is an example of very isolated population in mountains of the Richtersveld.
All right, let me ask Massimo this question then. Firstly, the naming of it, and also, why are Namaini weevils important scientifically? Do they matter?
Well, they live in the soil. They are isolated. Phylogenetically also they are very isolated. So the knowledge of this group helps understanding the relationships which are spread between all the various groups of these weevils in South Africa, not only South Africa. But when we first collected the first ones, we thought they were belonging to a tribe Trachyphlaini, because they are very similar. They have the very same kind of life. Then we make more investigation, and actually we discovered that they actually belong to an entire new tribe, completely isolated. So this means that this tribe has evolved independently from all the other tribes of the Antimini subfamily in South Africa. All the species that we have found, now we have many genera, not only the new genus and the 6 that we have discovered recently, but we have been working on this group for the last 10 years, 15 years. And so we have now many other new genera that we have described. So this is a completely isolated evolutive group. So this is why it's also phylogenetically very important to have recognized this lineage.
And I just want to then, as Massimo was speaking about evolution, Roman, so these beetles have been surviving blistering heat and extreme drought. What physical or behavioral adaptations or attribute would allow them then to survive where most insects would die?
Roman?
Yeah, I'm here.
Yes. Did you hear the question, Roman?
It is difficult. Yeah. No. I think I understand why beetles are able to survive in this extreme drought. Yes?
Tell us a little bit more about that.
It is difficult to say. They are adopted for this life by their morphological characters. Their extremities are shorter and more robust in comparison with the other weevils from ground parts of plants. Their eyes are very small or even missing. They use special vesture for covering their body. But how they are adapt for life in dry and hot conditions, it is surely topic for many other observation in field. We know almost nothing about their bionomy and physiology. We know nothing. We don't have any observation of their life. We don't know where is their oviposition, where they have larvae and pupate. Their ability to survive in very dry habitats is very exceptional. One time I put the soil, sifting soil from South Africa, very near to hot heating, and I was able to observe and collect living weevils for 4 months. All other small arthropods and spiders and so on died during 1 week. These weevils were able to survive there for 4 months.
So, Massimo, I'm curious as to whether these species are specialists. Do they survive on particular plants, soils, or microclimates? And I also want to learn from you how you combine traditional morphology with modern DNA tools to prove that these species are genuinely new. They were previously unknown.
Well, this is quite interesting because, of course, we are using morphology since a lot of time. And the basic to discover if species are different is just comparing morphological characters. We have made also molecular analysis, but for discovering, deciding if a species is different, we have to check basically mitogenome, so cytochrome oxidases, which differs between species. So when you have very similar, morphological similar animals, then now it is possible to make a research with their cytochrome sequences. If you consider, for example, that all humankind, 8 billion people, our variation is about 0.2%, but we are different from the chimp, 8.9%. So this is a very, very good marker. And first of all, we are doing some morphological analysis. Then we also have to consider that these animals are very, very slow moving. They are not able to move from one place to another one. And so they are small population, isolated since a lot of time. And therefore, this is why they tend to become different species. The number of the specimens is probably not so high. So there are some genetical drift and other genetical mechanisms which lead to a quite quick speciation. Usually, if you are working with moving animals, you can try to make crossing and do these things, which is not always easy to do and also not always giving a perfect answer. But in this case, we are mainly working because it's easier with morphology. Then maybe I can speak later on if we have some time. We can do also some molecular analysis. But we did the molecular analysis in this group just to see the relationship, the phylogenetical relationship, so working at a different level from single species differences. But also, we can also do the molecular analysis for discriminating about among different population and discovering different species which are very similar one another.
All right. So let me just very briefly, Roman, come to you on the issue of climate change and what it says really about ecosystems, climate stress. Is it possible that there were other neomani species before and they became extinct? Roman?
Once more, please, question.
Is it possible that there were other neomani species before and they became extinct because of, the changing climate, the various ecosystems we're seeing now?
Insects can react to small changes in their environment much earlier than humans can detect them, even with modern devices we have. Thus, extinction of some insect species can truly be an early warning to humans.
All right. Massimo, I'm going to end with you. There's the ethical dimension. Why was it so important that these beetles are recognized as coming from South Africa, particularly in your naming? Their type of specimens are going to be housed in the Dizong National Museum of Natural History rather than overseas. Why was that important for you?
Well, we are quite aware that quite often Africa has been exploited by entomologists or zoologists or botanists from all over the world who went to these countries, grabbed everything and took to Europe or to America or Japan, just describing things and keeping things for themselves. We would like to do something more ethical. I mean, these animals are belonging to South Africa, so this is why we are decided to name one genus after the Nama people, because it is their material. We named another new genus after Khoisan people, because this is your true heritage. And this is also why we are not keeping our types in Europe. We keep part of material if we have many, but if we have a single or very few ones, we are depositing them to Pretoria National History Museum, because we think that they belong to South Africa. So we are studying this material because we have a lot of knowledge, and so this is also quite exciting for us. Also, traveling in these incredibly wonderful countries is beautiful. But leaving the material to South Africa means that we are cooperating with you. We are not stealing anything from Africa.
Right.
But our important thing is to cooperate with Africa.
And that's a very important note to leave it on. I thank you both for taking the time to speak to us. It's really an honor and a privilege. That is Dr. Roman Borovec, specialist in beetle morphology and classification, as well as Dr. Massimo Meregalli, an expert in weevil evolution and DNA analysis. So 6 new beetles have been discovered by these 2 esteemed gentlemen, an extraordinary find, and that was done in Richtersveld. And that's how we end Africa World Hour this evening. Thank you so much for joining us. Do enjoy the rest of your listening, viewing here on Channel Africa. Up next is Shaila Ndukumana and African Diaries team.